Hello, my name is Jana and I would like to show you our robotic imaging system RadalyX in the virtual reality. So here we are in a hangar and we can see the system right next to us. The robotic system is composed of two robotic arms. One arm is holding the X-ray tube and the second arm is positioning the imaging detector. Robots are moving synchronously so that the X-ray tube always points at the detector. Now I will move to the second scene where the system is transported right next to the airplane. We can achieve this thanks to the portability of the system, and we can see that one arm is positioned above the wing and the second arm is positioned below, and the robots are taking projections. We can measure like this even the whole wing and then stitch all the projections into one final image of the wing. Now I will move to the next scene where we can see the system in the configuration where one robot is sitting inside the airplane and the second robot is standing outside the airplane. We can achieve this configuration thanks to the precise calibration of the system, so we can transport the system literally anywhere, even inside the aircraft like this. We can inspect some critical parts of the fuselage like cracks or even foreign objects inside the fuselage. On the screen we can see the operator control software where we set all the imaging parameters or the scanning geometry in any easy way. In the next scene we see both robots on the same side of the inspected object. This approach is called backscattering, and we use it when we cannot place the inspected object in between both robots. We don't measure the radiation that is passing through the object, but we are measuring the scattered radiation. And with this approach we can scan very large objects or objects that have complex shapes. The big advantage is that we can see some defects that are hardly detectable on classic scans, like gaps in between layers of materials. The example of backscattering scan is visible on the first scan, where we can see slices from different views. This image is an example of a measurement approach called tomosynthesis. The image is a comparison of two scans. The first is a standard 2D scan where we cannot see any defect, and in the special tomosynthesis measurement we discovered very tiny cracks in a wooden core. Next scans show insert and potting compound and glue around the insert in different layers, and the last scan show cracks in a landing gear, where in the first image is a 2D scan of film radiography where the defect is not very visible. Then we can see scans done by our system where the defect is nicely visible. Thank you for your attention, and for more information you can visit our website radalytica.com.